Hidden Layers. Meet the people behind the data with Uri Elabayev.
Hi everyone, my name is Uri. We are now in a new podcast of Hidden Layers. Today we have a special guest from NiCE. We are at the NiCE World Conference in London. I'm going to talk today about agentic workloads, how customer support are using AI, and many interesting topics. And I would like to present your guest for today, Benjamin. How are you?
Good, thank you. So nice that I have the chance to be here in your podcast. So a little bit about myself. I was the former co-founder and chief software architect of Cognigy. So now, after the acquisition, of course, my title is different. I'm responsible for NiCE Cognigy's software products and their software architecture. So key aspects that I really care of are scalability, and what if the biggest customers really send a lot of load on systems, and many of the things in customers, they take those things for granted. Yeah, systems will scale, we are in the cloud, all of this is infinite, but of course it's not like that. Systems need to be designed in order to scale properly.
Exactly.
And that's what I'm responsible for.
Can you please elaborate more about Cognigy and what you are doing? What is the mission and what are the technology that you are working on? So our audience will be more familiar what you are doing, and then we'll talk about the technical stack of what you are doing.
Sure. Maybe I start a little bit with a fairy tale.
Oh, nice.
I think your audience will like it.
Yeah.
Because when I actually met Phil and Sasha,
the co-founders.
Yes. Our mission was very different. We actually had this very interesting idea of building a speaking teddy bear. And the speaking teddy bear the idea was I have a high-tech toy. It has some sort of speech-to-text, text-to-speech technology built in. We would do everything on device. It needs to have context, and it needs to be smart. It needs to remember things. Like if I'm a kid and I interact with my teddy bear, right? Maybe the very first time ask for my name, but then it knows my name, it knows my favorite color. And then we said, okay, once we have the teddy bear, we could actually replace the teddy bear with a Disney figure or anything else. And then very quickly we realized it could also be a smart fridge, or it could be a house, actually. And so we searched for use cases where we have a lot of volume, and we immediately figured out, okay, customer service is where you have a lot of volume. Many customers call their internet service provider, their airline. And this is why we said, okay, let's maybe not focus on the teddy bear, but let's actually focus on building a software platform that maybe Disney would use to then design dialogues that a teddy bear could have. And what we also rather quickly realized that the speech-to-text and text-to-speech models back then, and this was like end 2016, early 2017, like pre-Amazon Echo.
Wow.
We realized that the speech-to-text and text-to-speech technology is not really there yet from a quality perspective. So we said, okay, let's maybe drop the voice part and first focus on building a platform that processes text. So we started to build what we call Cognigy AI, our enterprise-grade conversational AI and Gen AI platform. It's a platform, our customers use it, and they build agents on top of this platform. So we give you a lot of building blocks. We have a proprietary NLU system that supports more than 100 languages. It runs inside of the product itself, so it does not have any external dependency. We have what we call the Flow Studio, where you model dialogues. And over the years, we added a lot of capabilities that the largest enterprises on the world would use to deploy AI agents, conversational AI products at scale.
Wow, super interesting. And you were bought by NiCE 1 year ago, right?
Yes, was like September or something like that.
Time flies very fast. Yeah. For $1 billion, this is according to media outlets.
Yeah.
And now I want to deep dive about the technology and what you are building, because you managed to serve a lot of customers. You said at the beginning the importance of scale, right? How you need to build things that will last. So let's talk a little bit about what NiCE and you as a Cognigy do in the field of AI. We'll talk about a little bit about the stack, and then we will deep dive about agents and what you are doing. So give me a short explanation about what you are doing in that field.
Yeah. So I think now that LLMs are around for couple of years, and everyone is using ChatGPT and Claude and other agents and also personal agents. Many of the customers that we talk with have the impression that LLMs are the critical piece, but what I think only very few customers realize that the LLM is something that you need. It somewhat replaces natural language understanding that we have used in the past, and it also combines this with creating outputs in a nice, readable, specific or situation-aware language. But what was, in my opinion, much more important than the model is the harness around that model.
Super agree with you.
Because you want to control what the model does. You want to use the right model for the right choice. A couple of examples. A GPT 5.5 may have really good reasoning capabilities, and we also have the 5.6 model now with Soul and but it's not suitable for a conversational AI case that you want to deploy in a contact center because it's not fast enough. So
and it's too expensive for that.
It's too expensive. It's not fast enough, although it might have the best reasoning capabilities or pretty good reasoning capabilities. So what you need is a platform that you can use to build your agents, but a platform that also guides you, as in which model should you use, and also what happens if this model right now is not available, because uptime is something that pre-LLM was something that we have completely solved, because everything was like self-contained. Cognigy NLU would run locally inside of the Cognigy AI platform, but now we somewhat depend on large language models. So it's a lot about orchestrating, and it's a lot about making sure that you can reach those models even at very busy times. So what we, for instance, have in our platform is a component that is called the LLM Gateway. And it implements a clever pooling algorithm that customers can use so that your GPT 5.5 call will always go through, because you can configure multiple GPT 5.5 inference endpoints, maybe one in Germany, one in Amsterdam, one in Sweden. We measure latency of the individual requests, and we steer via this LLM gateway that we send the prompt to an LLM that is available, that is fast. And we even protect you from things like somebody rotates an API key on Azure OpenAI, right? And now suddenly this API key is invalid, but you have configured your own large language models inside of our platform. So we have fallback concepts in place that you can use, that even in those cases, the platform realizes, oh, the API interface responds with an error. We will retry that request, but we use another model from the configured pool so that we can actually succeed.
So you build an entire ecosystem, and this is really fascinating because the majority of my audience are really interested in that, because there is a one thing to build a tool that can work, but when you are doing things in scale, you need to think about the thing that you just manage. And what really interesting for me is that you are working with real clients. You see that all the things that you are building actually have a meaning in real life.
Yes.
And can you share more about the things that you have built that are really specific for scaling? Because you mentioned things like the maneuvering of changing the models. Do you have more examples like that?
Yeah, sure. I mean, the LLM was one thing, and the LLM Gateway is one thing, where it is about redundancy. If you want to build a voice AI agent, you have the same problem that you need to cover for speech to text and text to speech. The voice-to-voice model thing is also very frequently coming up, but there's not such a huge list of vendors yet that build voice-to-voice models, and it's also about control, right? So what this LLM Gateway also does is it is basically load balancing, but it is also keeping track of all of the prompts that we have executed, so that you also have auditing capabilities, that if you are one of the larger enterprise customers and maybe somebody complains nowadays rather publicly on LinkedIn about the experience that particular person had with your chat interface on your website, then you want to be able to go back in time and go like, okay, what happened?
To investigate.
Yes. And other areas in the product are like, I mean, we all know somehow how an agent works. An agent is a combination of an LLM and a harness. And then part of the harness are things like skills, sub-agents, tools, instructions. Now, when it comes to tools, some of our customers are as advanced as, hey, we have APIs and we already deployed an MCP server, so can you just connect to that MCP server? But we also have many customers that do not have an MCP server, and they still want to run some sort of a business
Integration.
process, and they want to build an integration. So how can you do that? We actually 9 years ago, more or less, have solved this integration piece already, because in our dialogue editor, where you model the dialogues, it's not unlike what some of our competitors back then did, like Google Dialogflow and so on, which was a intent detection and slot extraction layer. Our system, our dialogue editor, combines detecting intents, detecting slots, but also running custom logic. So I can, for instance, have conditional branches. I can say, if the customer said hi, specifically written like this, all lowercase, then we execute a path. So what we built basically with Cognigy flows is like a graphical canvas where you can do visual programming. And we are now reusing this technology for system integrations, where you can say, do an HTTP post request to my CRM system, wait for the response to come back, then run a little bit of JavaScript code on top of the response, reformat the response, maybe extract some keys from the JSON that comes back, and then give that back to the LLM-based agent.
And this is happen using AI or LLMs, or this is like deterministic software?
The integration layer is the deterministic piece of software. It is, of course, informed by AI, as in my agent has multiple tools. One of these tools might contain such a structured workflow.
All right.
And then as part of that structured workflow, you can do whatever you want, run custom code. And here, for instance, when you talk about running custom code, which, to be honest, in 99% of the cases customers do, because the API responses of your booking API, they were not prepared for giving that response to the LLM, right?
Yeah, it's fascinating. You say you are waiting for other APIs to do their job while your LLM is much faster, but you need to have that in mind also, because you're not only waiting for the result of your API, you're waiting for the entire process to finish.
Exactly, right? And you also have certain APIs, even though they might be super quick and so on, the response was actually never meant to be fed into a large language model. So if my response body is huge and has 100 key value pairs, but only 3 of these key value pairs actually matter for driving the next step in the conversation, I pay all of these tokens, right? So it's also for cutting the costs. And then running these custom-built workflows at scale, as in right now for one particular customer, we might run millions of these workflows per minute, including custom JavaScript that some engineer on the customer side wrote, that we also need to isolate from other JavaScript that runs for another customer, right? This is another example where we build a runtime. The internal code name for this is Cognigy serverless, that gives every customer, every tenant, a completely isolated area where we can run their code, completely isolated from other customers' code. And then, of course, also scaling, executing this piece of JavaScript or your HTTP request, retrying that HTTP request that points to your CRM system that you may have not updated for 3 years, right? That may have availability issues. These are some examples.
Wow, super fascinating. You mentioned in a brief about the cost of tokens.
Yes.
So can you share a little bit more about, if you can, about how do you do the FinOps? Because this is something that many people are struggling when you are in scale. It's really hard, you can build things, but if you pay so much money for them and you're not doing this optimization, you can lose a lot of money. So what is your approach for that, or what you've developed as a technology in order to tackle some of those issues?
Sure. So I think it's multiple aspects. The first aspect is transparency. So you need to know, if you had a sample conversation with an agent that you built, how many tokens did you burn? Because you need to know how many dollars would you actually spend for this conversation. And we have the ability to keep track of token consumption. So we give you access to your input tokens, your output tokens, your reasoning tokens that you have used for either a turn or for an entire logical conversation. Then what we also do is we have a product functionality called the simulator. The idea of the simulator is that you build an agent, and especially if it uses an LLM, if it's a full agentic experience, it's very difficult to test this, because you can do like 20 tests
Yeah,
with your
there are
colleagues.
endless scenarios.
Endless scenarios. So what we build is the simulator. So what you would do is you would define simulation scenarios. The simulator itself uses an LLM because you can obviously only use an LLM to test another LLM-based application. But you define test scenarios as in your mission is to talk to this agent and buy all of the cinema tickets that are available, which is obviously something that you don't want to offer. Maybe you can buy
it's
3
against the
tickets, 5
policy.
tickets. And so, exactly. So you would define such a test scenario, and you would then run that scenario at scale with slight variations that our platform creates. Now, if you run 1,000 of these simulations and point them to an agent that is your cinema box office clerk or something like that, and all of these simulations are done, you can analyze the data that the platform generates and stores afterwards, and then you would know a bad guy that tries to get all tickets, but the agent says, sorry, the maximum allowance is 10 tickets per booking. And you try it again, and the simulated scenario tries it again and tries it again, and maybe tries ways to...
prompt injection.
Exactly. Then you know what this solution costs. And because we support...
But you say you know what is the solution cost, meaning that now you have the measure of this ping pong, how much does it cost?
Exactly, yeah. So you at some point you have a good understanding of even if somebody tries to abuse your agent, what would your costs be? And you can also use the simulator even for the happy parts to understand whether the agent is doing exactly what it should do. And what you can now do is, imagine you're running these simulations and you're using GPT 5.1 Nano. Then you get a cost report. But you might
you can simulate it.
Exactly. And you might now see after simulating 10,000 interactions, which might only take us like 3 minutes or something like that.
This is true.
That your average price for such a conversation would, let's say, be $7 or something like that. But then you change the model, because maybe the simulator also unveiled that there were some conversations that the agent could not resolve because maybe the model was not smart enough. So you now pick GPT 5.3 instead of 4.1. You run those simulations again, so maybe now you have resolved all of the inquiries, but the costs are...
Instead of 7, 9.
Exactly.
Wow.
And this is also a tool that you can use. Obviously, you will burn a small number of tokens for running the test, but you can also see, will this particular model work in my use case that is maybe super complex, that it maybe has like 7 skills, 35 tools. So you need a really smart LLM to handle all of this.
This is super fascinating. What is the approach of the clients to that? This is something that they are aware of, or this is something that couldn't care less? I guess they care about the money, but when they're running the simulator or you are helping them, the eventual outcome of that, this is the base model for you, this is how much it costs. So my question is how much of the clients actually care about which model they are going to use, or they only care about the cost of the conversation?
I think they care about... So usually we do demonstrations, and maybe in a demo you pick the fastest model and you pick the most expensive TTS model because the voice sounds so natural and so on. And customers like it, but I think any vendor on the planet does that because you want to show the art of the possible. But then, of course, if you do an ROI calculation, you rather quickly want to go back, right? And you go like, okay, but maybe we can exchange the TTS to something that sounds still pretty good, but is like only a fifth that expensive.
In a simulator, can you find a sweet spot?
You can find the sweet spot, but there might be some variations that you have to test. So what we also started to do, and we'll release that also very soon actually, is as of right now, the majority of our customers bring their own LLM, as in they bring API keys, right? So you go into Cognigy AI, and why is that? Because of compliance. Cognigy started in Germany. We have a lot of healthcare providers, banks, and if you tell them, hey, we provide the LLM, and the LLM is generating output text that goes just directly to their customers, they usually see a huge compliance risk with it. I think in the last couple of years it changed, right? So everyone had time to adopt, use ChatGPT, use Claude, realize, okay, well, it's actually not that bad. The hallucination rate is no longer 95%, right? It is so small if you have a good harness that controls the LLM, that more and more customers are willing to say, hey, if you would provide the LLM, we would just use it, right? We want to have an as easy as possible solution. I want to go into Cognigy AI, build my agent, don't care about the LLM, don't care about STT and TTS, but then of course they offload that work to us. So
and you are doing the optimization.
And we are doing the optimization. We are running, we have something internal which we call the model catalog. So once a day, we are benchmarking new models. Yeah. So I think meanwhile, it's like 24 hours. Sonnet 5 was released from Anthropic.
Yeah. Less than 24 hours, yeah.
So we are benchmarking Sonnet 5 already so that we understand, okay, for what use cases could we use it, right? If we have a sample agent in the aviation industry, and if we would use Sonnet 5, which I would not, but as an example, how much would a particular conversation cost? So that you also understand, is this a model that we could recommend, and is this a model that we could use behind the scenes if we provide the LLM?
This is per industry, per client, per what does?
So we, right now, we try to find, of course, we want to make it as easy as possible, but the model catalog also contains a lot of attributes, as in this is the fastest model, which is really good for a voice AI agent, but the limitations are that the response time, the good response time, comes at the cost of it gets really bad, as in using more than 15 tools, right?
Yes.
And
There's
then
a trade-off.
There's a trade-off, and then for the use case that the customer builds, we have some ideas also on things that we are not doing yet, where we can just say, okay, for your use case, based on the number of tools, based on the number of skills, based on the length of your instructions, we would recommend the following model. And then just use that behind the scenes, right? If you buy the LLM in a packaged pricing from us.
It's like internal open router in which you can tell the client, maybe on real time, maybe in a batch, you should use that model for that specific task, and then you are able to save money.
Exactly.
Or improve the latency, or whatever you want to outperform or improve, right?
Exactly.
And do you see that customers are starting to use those agents and actually to complete tasks? Because the most, let's say, complicated thing that I see, companies that use in production is that how do you evaluate the result? How do you know that the job is done? And so what is your philosophy for that?
Yeah.
Or what is your approach for evals of agents?
This is actually, I think, what set Cognigy apart on the market, and this is most likely also one of the reasons why NiCE actually acquired us. NiCE had this, and they still have, when they started conversations with us for the acquisition, they used a language where they said there's front-end agents or front office agents, there's mid-office agent, and there's your back office agents. An example for something that a human would do that would represent a back office would be a human sits in a contact center, or an invoice comes in via email and your finance department scans this email and does something. Pure back office work. Front office would be you have a traditional chat widget that is connected to a human on your website. Somebody goes on your website, says, hi, I'm interested in products XYZ. Then you have the mid-office type of situation where somebody doesn't have a leisure chat, but maybe somebody goes like, hey, can you change my address? And it's already somehow authenticated and you change the address. What we really focused on, and this once again goes back to this conversation editor where you model dialogues, but you also model backend interactions, as in call this API, run a little bit of code, but all in a low-code graphical user interface. The strength of Cognigy always was to integrate very deeply into your backend systems with CRMs, with ERPs, because the actual value is not the FAQ type of bot. The actual value is, and we do this for customers like Lufthansa, they build agents. It's called Lufthansa Chat Assistant. Maybe your community wants to check it out.
Yeah.
And you can book a ticket via this agent. You can rebook your flight. You can say, this is my booking identifier. End to end. And this is exactly what Lufthansa does when they have a union strike in Germany. We like to do union strikes, and then everyone has a problem, and you're at the airport, and they send out emails and with a link to the agent experience. You click on that link. This is also where the scalability kicks in, because maybe right now we are processing 600-700 messages per minute for them. Now suddenly you process 16,000 messages per minute. Within like 7 or 8 minutes, you have to scale up. And then they can just say, hey, I received the notification that my flight is canceled. Are there any alternatives? And then you pick one of the alternatives. And in order to pick the alternative, you need to fetch the alternative from a system, right? You need to serve that to the customer maybe in a nice graphical way with an adaptive card or an interactive widget. You select one of the alternatives and then you do the rebooking. And the ROI on this use case is of course humongous, because if you would actually call them and you would spend 7 minutes with a human agent to do the rebooking.
But I want to ask you a hard question. What technology nowadays made this possible that wasn't possible like 2 years ago? So because this is what I'm most curious about the agentic, the LLM. The other thing that you say, okay, this is possible only now with the current technology?
I would say with a system like Cognigy, it was possible 2 years ago or even 5 years ago. But the problem is that in a completely rule-based system, basically, I mean, we also had NLU as in it used machine learning, or it still uses machine learning because it still exists. But when you have to model all of these dialogues, you have to somehow assume what the happy path customer will do, but you also somehow have to assume what the non-happy path will be. As in, you say, hey, you canceled my flight, and the agent says, yeah, I need your booking reference number, and then you say, I really don't know how they look like. And then the agent says something like, oh, I'm sorry, I didn't understand. Because you pre-programmed the system for now receiving a 7-digit alphanumeric identifier and nothing else, right?
Yeah.
Now with LLMs, it is much simpler because you can just say, here's my agent, it has instructions. I give it 5 examples of how booking codes would look like. And even if I then say things like, my booking code is Bravo, Bravo, double Charlie, triple X, it would still figure that out because because of the LLM, we now have the reasoning capabilities to figure out that it is this code. And that was, of course, way harder back then. And this is, I think, why some customers were also a bit scared, as in, if I haven't thought through all of the edge cases, and too many customers run into an edge case, then you have bad publicity and so on. Yeah. So now LLMs to the rescue, you can now make this a much...
They are much robust.
Exactly.
Yeah. And I want to ask you one more question about security.
Yes.
So I'm guessing this is major concern, prompt injection, specifically like companies like Lufthansa, when people try to get free tickets, do you know those kind of screenshot in Twitter? There were people, I managed to get free ticket, or it was in Chevrolet, when you can buy one Chev in $1. So people try to take it to extreme. And also you don't want companies to let people extract data that is not supposed to be out there. So what is your, let's say, philosophy on that, on how do you manage to add this layer to your product?
Sure. I mean, every large language model provider, like Azure OpenAI, for instance, they have a lot of content filter capabilities.
Yeah, guardrails.
On their side, on the LLM side, your harness obviously needs to be aware that these things exist, because if you then say something and then in the background a prompt is generated, we send that to the LLM, and the Azure OpenAI in this case says, sorry, content filter kicked in, then our platform needs to be aware of, let us retry this, as in rephrasing the prompt, or we somehow need to get back to the customer, and you can model fallback paths that you then use in those cases that are maybe not even using an LLM, or maybe you want to use a different LLM, right? Yeah. Which is also possible, of course. So integrating with these content filter capabilities of the providers is one thing. The next thing is the simulator, because in the simulator, you can now obviously also create simulation scenarios that try to attack your agent.
For abusing.
Exactly. And then you run these simulations at scale, and here, the important part is also that you once again maybe want to compare models, because different models behave differently. Analyzing conversations after the fact is also something that we are now doing, where maybe somebody did a prompt injection and maybe somebody somehow got access to information, and there is no 100% way on how you can defend against that. But if that happens, you also want to have a system that flags this type of conversation after the fact and tells you, here are conversations where there was a compliance type of problem, so that you can actually close the learning loop and change the next version of your agent. And maybe, and that's also interesting, also create a new simulation scenario automatically, so that next time you have one more simulation scenario that you can run in order to verify that this is no longer the case.
So you can change the policy based on a real conversation.
Exactly.
When you flag that there was a problem.
Yes.
And then you can create a new simulation that you will practice on that for future reference.
Exactly, right? And because our simulator, for instance, and there's many products out there, there's even entire companies out there that build these simulation type of
I know.
products. We also, for instance, added mocking capabilities, right? Because if you run these simulations, you don't necessarily want to hit all of your APIs all the time, or maybe you also want to act as if one of your APIs returned an internal server error, because you want to test what is my agent actually doing if this is the case. Like, what is my agent doing if the LLM that is used to drive the logic of this agent returns a content filter error, right? Does your entire agent from outside, if you treat it like a black box, does the black box still behave in a way where you go like, okay, we may have a static message that we send back to the customer or something like that?
Yeah.
And you can even test these scenarios, because for everything in this graphical process editor that we have in the flows, in the Cognigy flows, for each node and each piece of functionality that you can place there, you can also define mocks that you then use in different simulation scenarios.
Wow, super fascinating. So you see that everything is mixed together. So this entire process of the evaluation, the simulator, as well you are running. So the simulator can help you for quality, but also for cybersecurity or attack or abuse that people are trying to do.
Yes.
And I want to ask you a little bit more about the data.
Yes.
Because I think this is what makes NiCE so unique in that field. Because nowadays people could argue that you can take a really strong engineering team with LLMs and build the majority of the things we talk about today. And I want to ask you a really unique question. NiCE has been doing that like 20 years. You are doing quite a lot. How the data element and your unique proprietary data that you have can differentiate you from other players that will try to build something similar nowadays in like 6 months and try to compete you? So where is the data element of your work?
Yeah, so I think data is really important, but what is even more important than that is how you use that data and for what you're using that data. So we have a bit of a paradigm when we do keynotes and so on, and we talk about where in the platform we could add AI. Then we very often talk about that this is literally our name that we've picked for it, the circle of life for an AI agent. Because when we started to build Cognigy as a company and then Cognigy AI as the product, we were always thinking about you start to build, so you build your agent, then you somehow deploy it, let's say on WhatsApp or on Line Messenger, on Telegram. Then it runs, it produces analytics data, then you somehow learn from this so that you improve it. But you don't have to start with building. What if you already have tens of thousands of emails? What if you already have conversations that your end users had with contact center agents? And this is what NiCE has as one of the biggest contact center providers. And you could move from starting with building to starting with analytics, analyzing the conversations that you had, discovering agents that you could build. And this goes up to a point where you analyze the data, you at some point automatically generate the agents.
Yeah, we saw that in the demo, it was nice.
Then you automatically generate test cases. It's a bit like what you do in machine learning. You have 100 million documents, that's your total data pool, and then you take 70 million of them and you use them to train a model, and then you take 30.
Yeah.
And here you can do the same. We take data, we generate agents. With the rest of the data, we generate simulations. We run these simulations. We could bring in model variants, as in we run these simulations with the following models of different providers. We create artificial conversations while running these. We analyze those and understand, did we fulfill like the business needs that the human agent may have documented as part of their after call work, for instance, right? Customer said something, human agent guided through a process, human agent in the end flagged this conversation as we booked the ticket. And now you get into a system where you don't start with build, you start with what you already have in terms of data, then you generate instead of building. This is basically what all
the
software
paradigm
engineers
shift, yeah.
Then you test that, you deploy that at scale, you create even more data, which is then tagged as you have created it as part of a simulation or then as part of your deployment, which then even allows you to compare different versions of your agent, right? So you can do things like, this agent performed 20% better, had 5% higher CSAT last week than this week, but you also deployed a new version. So you can also automatically revert back and do a roll.
Do you have like aggregated data? Because you're working with so many clients. And let's say I am now a new flight company.
Yes.
And I want to open a center and let people. And I don't want to start from scratch to build and train my agent. Do you have like a common knowledge, common sense? So I won't be started for building the agent only when I have my own data?
Sure. We have for the different industry verticals, we have fully prepared templates, because obviously you are either in aviation, you are either in banking, you are either in insurance, right? You're either.
We all have the same conversations.
And you have somewhat the similar conversations. And even the integration patterns are similar, right? Every airline has a booking system. Every airline has some sort of a system to notify and send notifications into their mobile apps if flights are late and so on. So that's a templated approach that we have that we use also to get you started much quicker.
Super interesting. One last question. I would like to talk about the future. So what do you think will be the future of agents and how people will interact with them? So this is also a technical question, but also more like philosophy or social questions about what do you think the people would look when they are engaging with customer support, let's say agents?
Yeah. So there's obviously things that we do, that NiCE does. There's also my personal opinion and maybe also a bit of my dream. Yeah?
Go ahead.
So part of this founding story of Cognigy also is Phil, Sasha, myself, and the first couple of engineers. We are all Star Wars nerds and sci-fi fans. But we are sci-fi fans because we all like this idea of you have a robot like R2-D2, C-3PO. They can manipulate objects in the real world, but you can also have an interaction with them. They remember things about you, and you have Star Trek with the computer that you talk. So I think what somehow unified us from the get-go was this drive of, okay, what could be a possibility in the future? Now, going back to large language models and what we are all doing on our daily lives, also using ChatGPT and Claude, what I believe is that right now, humans are reaching out to brands like airlines. But in the future, and all of our customers, right, they act as if their customer is a human. But
you will be serving agents.
What if it's Siri AI?
Yeah.
What if it's really Gemini that like Google announced that years ago with the hairdresser demo, right? What if I just tell my phone, I need a hairdressing appointment next week, make it possible, needs to be on Wednesday.
Yeah.
What if this agent, my personal agent, calls all hairdressers in a 25-kilometer radius around my place where I live, maybe even calls some of them multiple times, is super annoying as in, no, I need to get that slot, right? Are you, as the enterprise, prepared that the number of calls that you're handling right now will 10 times, 20 times, 100 times more in a couple of years? And then your customers are no longer humans, but AI agents that do things on behalf of humans. This is a very interesting idea, because if you play it through, then at some point AI is interacting with AI. We already have this in the sense like somebody sends me an email, AI summarizes that email if it's too long. But if I want to compile an email, I might use AI as a starting point to compile this email. So we are obviously all burning tokens like crazy, right? So
instead of just writing the bullet point.
Exactly. But this is just how language works, right? We want to have a bit of a more elaborate conversation, like
more
the one
dimensions.
we're having. Yeah. And so what I believe the future is, each of us will have a personal assistant as part of my phone, as part of a device that I have at home, maybe as part of my smart home experience, And these personal assistants will do something on behalf of me. This will lead to a much higher load for our customers in their contact centers, load that they will not be able to manage and handle if they haven't prepared for that. And if I'm not doing something by telling my personal agent that it should do something on behalf of me, but I use my tablet or something like that, the interfaces are also changing. Right now, if I want to order a pizza, I open the Delivery Hero app that a company built to offer this service. In the future, I open the ChatGPT app and I just say, I want a
My
pizza
regular
margarita.
pizza. Yeah.
And then ChatGPT checks what services are surrounding where you live, maybe even compares prices, compares reviews, and so on, and then just orders that pizza. And then things like websites, they will somehow die.
Yeah.
Because right now we have our websites that we had for 50 years or 40 years. We put a chat widget on the right bottom corner, but the website of the future is either just an input field.
Maybe an empty file.
Yeah, or you don't even have the website, because all of what the companies do is they publish their information, their services as agents, and then my personal agent can interact with those agents and figure out a deal or order something.
Super fascinating. We are now starting to get used to a future where not only humans are using technology, but also agents. You see that in payments, you see that in maybe security, logins,
Humanoid
everything.
robots,
Yeah.
right? Humanoid robots could be the next iPhone moment, right? And there's so many companies, there's so much money and investments. Boston Dynamics now fully bought by Hyundai. Figure robots in the US. The Tesla Optimus robot, right? Now these will all also use some sort of a conversational AI, Gen AI type of interface to interact with us. And then it even gets worse, because now suddenly it's not like my personal assistant on the phone line talks to the enterprise. It's also like my personal robot may call, or my personal robot does something in the physical world for me on behalf.
Wow, super fascinating. Thank you for this amazing conversation. I personally learned a lot. And that's it. Thank you.
Thank you. Welcome. Thanks for having me.